Hey everyone, so the video right now is on Introduction to Graphical Limits Day 1. The first thing we're going to talk about is actually what a limit is. So a limit of a function f of x describes the value of the function close to a particular value of x. It does not necessarily give the value of f of x. So we write lim x approaches c of f of x equals L. And the way that we read that is we say the limit as x approaches c of f of x is L. So if we look at this picture over here, here's our value of x that we're approaching, so c. We're approaching from the left and we're approaching from the right. So if we actually look at our function, here we are approaching c from the left and approaching c from the right, and we can see that even though that's an open circle, they're approaching the same value of L. So that limit as x approaches c is actually L, even though it's an open circle right there. So the actual value of the function at a given x value does not affect the value of the limit. We're going to talk a lot about that, okay? But this is the most basic picture of it going on, is just an open circle. The y values are still approaching this value of L, they just don't equal it, and that's okay. That's what a limit actually is. So when we look at limits, we actually have three different types. We have right side, left side, and then we have overall limits. So a right-sided limit, clearly, is going to look at the behavior of the function as x approaches a given value from the right side. So we still very similarly write limit as x approaches c, but now because we're approaching from the right, we're going to do just a little exponent of a plus sign of f of x equals L. So we say the limit as x approaches c from the right is L. Okay, so if we look at this graph over here, there's clearly a break right here, okay? And this is a break at x equals 2. So if we want to look at the limit as x approaches 2 from the right of f of x, we're going to look at the right side, which means over here, and we're going to look at what y value that's approaching. So that would actually be 8, okay? Then we're going to look at a left-sided limit. So obviously a left-sided limit looks at the behavior of the function as x approaches the given value from the left side. So we write the limit as x approaches c from the left, and now we just put a little minus sign instead of f of x equals L. I'm not going to write it out in words. Again, you guys can if you want. It's the limit as x approaches c from the left of f of x is L. Okay, it's exactly the same as up here, just left instead. So if we look at this graph and we wanted to do the limit as x approaches 2 from the left of f of x, well, here's our function. Here's 2. This is coming from the left. So over here, I'm approaching 6. Okay. Then we have the two-sided limit. So a two-sided limit looks at the behavior of the function as you move towards the given x value from both sides. All right, a two-sided limit only exists if the limit as x approaches c from the left of f of x equals the limit as x approaches c from the right of f of x. So in other words, a two-sided limit only exists if both one-sided limits approach the same value. All right, so if we were to look at this graph over here, if I wanted to pick -4, from the left side, my function is approaching 2. From the right side, it's also approaching 2, which means that overall limit does in fact exist. If, however, I jump all the way over here to x equals 1, then from the left side, my function is approaching 4, and from the right side, my function is actually approaching negative 2. So for this one, the limit as x approaches 1 of f of x does not exist. And the reason for that is because the limit as x approaches 1 from the left of f of x does not equal the limit as x approaches 1 from the right of f of x. All right, and that's what we're showing here in this picture, is this jump here causes a problem with our overall limit of x equals 1, or as x approaches 1, excuse me. All right, we are going to race through these problems really quick. So the limit as x approaches 1 from the right, so I want to find x equals 1, and I want to approach from the right side. So that's looking here. So that is actually going to be positive 1. Then I want to figure out the limit as x approaches 1 from the left. So that is right here, and that is also 1, which means the overall limit as x approaches 1, it exists because these two are the same. They approach the same value, which means that overall limit is also 1. Okay. Then we want to look at the limit as x approaches 2 from the left. So here's 2, and from the left, we're going to be looking at this portion here, which means we're approaching 2. And then the limit as x approaches 2 from the right, so we're looking at number 5 now. So here's 2 from the right. That's going to be this part up here, this green part that I'm drawing in. So that is going to be 3, which means when we look at that overall limit as x approaches 2, that one does not exist. All right, and the reason for that is because the limit as x approaches 2 from the left of f of x does not equal the limit as x approaches 2 from the right of f of x. Anytime you get a function that does not exist, you have to tell me why it doesn't exist. All right, we're going to be working with this definition a lot. Two-sided limits only exist if the left side and the right side equal each other and they are the same value. Okay. Then let's look at the limit as x approaches 3 of f of x. Well, here's x equals 3, so that is this dot right here. So there wasn't a dot drawn there, and that's okay, guys. There's still a value right there. As I approach from the left and from the right, it's clearly approaching that value because there's nothing wrong right here. So this limit is just 1. All right. And then the limit as x approaches 4. So again, we need to look at the left and the right sides together. So here's x is 4. So from the left, it's approaching 2. And from the right, it's approaching 2. So the overall limit is actually 2. It's okay that there's an open circle there. I'm just looking at what the values are getting really close to from the left and the right. Okay. Moving on. This is the same idea, except now we're going to be looking at some limits maybe involving infinity and negative infinity. All right, so the limit as x approaches negative 2 from the left. So if we look at negative 2, that's this vertical asymptote right here. So negative 2 from the left, that's following this pattern right here. That's shooting up to positive infinity. Okay. Then if we look at the limit as x approaches 1 from the right, so here's 1, and from the right side would mean we're looking at this portion right here. So that's going up and up and up and up. That's also approaching infinity. The limit as x approaches 5, well, here's x equals 5, okay? And from the right side, it's going up to infinity. From the left side, it's going down to negative infinity. That means then that this one does not exist. Okay, and again, we need to write a because. So the limit as x approaches 5 from the left of f of x, well, we know that's negative infinity, right? This is going down. And then the limit as x approaches 5 from the right of f of x. And we know that those two values are not equal to each other. So the overall limit doesn't exist. And we can tell that just by looking, right? At x equals 5, there's a vertical asymptote. So on both sides of it, they're doing something different. All right, now we need to look at the limit as x approaches infinity of f of x. So as x approaches infinity, that means as x gets bigger and bigger and bigger. So we're following this here. And if we look, there's a horizontal asymptote at 0, which means this is approaching 0 as it gets bigger and bigger and bigger. So the limit as x approaches as x approaches infinity is 0. Okay, and then we have one more to look at, the limit as x approaches 0 of f of x. Well, here's x equals 0, and there is a function value right there. So if we look at it, we can look from the left and the right, and we can see that that value is -1/2. Okay, it's between 0 and -1. We are actually going to do this sketch together when we get back to class tomorrow. So I hope that was okay. Please write down any questions that you had, and we will talk about them in class. All right, I'll see you guys later. Bye.